Hello, Algebra 2. We are starting Unit 7, all about rational expressions. We have been talking about rational numbers. Remember, the word rational just means a fraction. So everything that we are dealing with today is going to be a fraction, and we'll be able to use factoring to help us simplify. All right? Let's take a look at what I am talking about. We started the year when we were talking about types of numbers, and we said that a rational number is just a number that can be written as a fraction. So it's an integer or a fraction, basically. If you can write it as a fraction, it is rational. That means a rational expression is basically an expression that you can write as a fraction or a ratio. So whenever you guys see that word rational, it just means we're going to be looking at fractions. Let's take a look at a couple examples. If you guys have 6 divided by 3, right? That literally means 6 divided by 3, and we can simplify that to 2. The difference between having a rational number like that and having a rational expression is when it's an algebraic expression, you have x's, right? We've got variables. So I'm saying that x squared is divided by 5x minus 1. Last unit, we did this division by long division or synthetic division. We are going to take a look at how we can do it with factoring today. So we're going to really utilize our factoring, all right? So let's go ahead and simplify what we already know how to simplify. If you guys are given 2 numbers, like 20 and 64, and you're told to simplify, that means I'm going to take 20 and 64, and I'm going to think of what common factors they have. So if I want to simplify 20 divided by 64, I know that, let's say, I know 2 goes into both of them. So I know that I can say, well, if I divide by 2, this is really 2 times 10, and this is really 2 times 32, and my 2's will cancel. So now I have 10 over 32. And I know I can still reduce 10 and 32. This could be 2 times 5, and this could be 2 times 16, and my 2's cancel again. So now I'm left with 5 divided by 16. Since 5 and 16 don't have any other common factors, that's as far as I'll go. Let's try the same thing with some x's, with an algebraic expression, right? 4x squared and 6xy. So right now, I know that 4x squared means I actually have 2 x's. So I can write this as 4 times x times x. And 6xy is just 6 times x times y. I'm going to grab a different color because I think it will make more sense, just so you don't see the red over red. But I see a common factor that I can cancel out here. X divided by x makes 1, so I can get rid of those x's. And I also know that 4 and 6 both divide by 2, so I could cancel out 4, divide it by 2, and I could cancel out 6 and divide it by 2. So now my final answer winds up being 2x. I'm going to put those 2 over here, and 3y. I'm going to put those here. Okay? So then that's my final answer. Since we've been factoring, we can now do this with pretty much any expression that you're given, as long as you can factor it. So let's take a look at a couple more challenging problems. Starting easy and getting harder, all right? We know that we can, cancel out common factors, but remember, factors have to multiply. So I cannot cancel out any terms that are separated by addition or subtraction. I can only cancel out factors because factors are multiplied by each other. So the opposite of multiplication is division, which is why I cancel, because when I divide, I make 1, right? The same term in the numerator, or same factor in the numerator and denominator that divides and makes 1. So if you look at example 1, I only have factors because I do not have any addition or subtraction. So I have 2 times 6, and then it divides by 2. Since I have a common factor of 2 in the numerator and denominator, I can cancel those 2's out, and I'm left with 6. Similarly, in number 2, I have 4x divided by x. I do not have any addition or subtraction, so I can cancel out x, and I'm left with 4. If I look at number 3, I have 2 factors in the numerator. X minus 2 is multiplying by x plus 3. So even though I can see addition and subtraction symbols, they're inside the parentheses, so they're part of the factor. X minus 2 is one factor, and x plus 3 is the other factor. I have the same factor in the denominator. If I have the same factor in the denominator, then this x minus 2 is going to cancel with the other x minus 2. Not half of it, not part of it, the whole factor, x minus 2. So what I'm left with is x plus 3. In number 4, you notice that I have 5 times x plus 1, and then I'm dividing by x. If you look at where the x is, though, this x is in the denominator, and this x is inside the parentheses. So it is not a factor by itself because it's adding to the 1. So I can't cross those out because they're not factors. X is not a factor when it's inside with a parentheses with the 1. X plus 1 as a whole is the factor, but x by itself is not. So this one is already simplified. I cannot simplify it any further. If we look at number 5, you will notice a similar situation. I see this 4x minus 1 here, and I see it here. However, the 4x in the numerator, 4x minus 1, is not a factor because it's adding to the 3x plus 2. If it looks like it's adding, it's not a factor, it's a term. So it is not going to be canceling out. They have to be multiplying by each other in order to cancel them out. So again, number 5 would already be simplified. In number 6, I have x plus 2 divided by x plus 2. The entire term is by itself in the numerator and in the denominator. Since that is the only thing that's in the numerator or denominator, and they're both the same, I can cancel them and I can treat them as factors. So x plus 2 can cancel, and any number divided by itself is 1. So x plus 2 divided by x plus 2 is just 1. All right? Number 7, I have 3x minus 1 in the numerator. I have 3x minus 1 squared in the denominator. What this really looks like is 3x minus 1 is by itself, and then 3x minus 1 is repeated in the denominator. They are factors, though, because they are multiplying by each other. That's how we got the squared. So that means I can actually cancel out one of the 3x minus 1s. That could cancel with either of the 3x minus 1s in the denominator. It doesn't matter, because all we'll be left with is 1 over 3x minus 1, and that would be our final answer. Last but not least, if you look at where the x is in number 8, this x and this x, those are very tempting for students to want to cancel out. However, the reason why we can't is because there is a plus sign between them. So that doesn't make it a factor, it's now a term. And I can't cancel out terms, I can only cancel factors. So again, this one I would not be able to do anything with. I would have to say that it is simplified. Right? So with all this discussion about factoring, we are going to take a couple problems that are not factored already for us so that we can see how we would actually simplify them on our own. All right, guys, so 2 examples here. With this problem, we're going to try to simplify first and factor if we can, and then go ahead and rewrite our actual answer. So for the first one, part A, we do not have any addition or subtraction symbols. So all of these items are just multiplying by each other. 9a squared times b cubed. Let's see if I can make this a little bigger for you. Okay? So 9a squared and b cubed, I would like to just simplify it. So this is just like the last unit that we finished. I'm going to look at the 9 and the 27. 9 divided by 27, that reduces down to 1 over 3. Then I look at the a's. I have a squared divided by a to the 4th, so that leaves me with a squared in the denominator. I have b cubed divided by b to the 4th, so that leaves me with b in the denominator. And then I also have this c. There's no other c, so the c remains in the denominator. I have nothing else to do. I can't simplify any further, so I know that I have simplified as far as I can. If you guys come across a problem, though, where you have addition and subtraction symbols, like this one, we must factor. So now that we've practiced factoring a little bit, the first thing I always check for is a greatest common factor. And if we take a look at the numerator here, there is a greatest common factor because 5 can divide into 10 and 15, right? So and they also both have a y. So I can actually take out 5 and y, and now I can rewrite what I have left over. So I have 2y plus 3. That is my numerator, and that is my step 1. To continue my step 1, I also must factor the denominator. Again, 5 and y is in common, so that is my greatest common factor. 7y minus 1 is the rest of my denominator. Step 2 is going to be to simplify. So I basically just have one additional step. Step 2 is to simplify. And I do see a common factor in the numerator and denominator. They both have a 5y. So that means I can divide 5y by 5y, and I will be left with just 2y plus 3 divided by 7y minus 1. And that's as far as I can go because now I don't have any more factors because these are adding and subtracting with one another, so I can't cancel them out. Let's take a look at 2 more. For these two, all right, I'm going to go and bring these down. For these two, I basically just put 2 together because I'm multiplying. When you multiply, you guys know that you multiply numerator times numerator and denominator times denominator. So if I'm multiplying numerator times numerator and denominator times denominator, it really is the same as if I just put them together as one fraction. So I could rewrite this as n squared minus 6n divided by, and I have n minus 6 multiplied by n cubed. So I could rewrite it like that if I wanted to. It would be the same thing, okay? So that means my step 1 is to factor each of the rational expressions. That is my first step. So I'm going to come down here, and I am going to factor. If I have n squared minus 6n in the numerator, I'm going to go ahead and pull out n as my greatest common factor, and then n minus 6. In the denominator, I have n minus 6 and n cubed. That is actually already factored, so I can just copy that. I notice that I have a common factor, n minus 6, so I can cancel those out. I also have an n here, and I have 3 n's here, so I can actually take one of those away as well. And now I don't have anything left in the numerator, so I can just put 1, and I have n squared in the denominator, and that gives me my final answer. Okay? Go ahead and pause the video here, try the second example, and then push play to check your work. Placing our binomial factors together and factoring, canceling out, leads us